Hey everyone, in this video we're going to be talking about vectors. So this is a little bit of review from one of our videos from last chapter, but now we're going to actually talk about how to do things with vectors, how to add, subtract, multiply, divide, and how to work with them, which is going to be very important for our projectiles unit. So just as a reminder, the definition of a vector is it's any quantity that has both magnitude and direction. So the example that we've already given for this is velocity, because we're going 50 meters per second north. But that's not the only kind of vector we could have. We could have displacement, we could have acceleration, and later on in the course we're going to be talking about force vectors and fields and all sorts of different things that are vectors. And so far in one-dimensional motion we've only talked about a vector as being positive or negative. So for example, if we said that the acceleration is negative 9.8 meters per second squared, what we're saying is it's downwards. So we've only dealt with really two directions. But now, in two dimensions, we have an infinite amount of angles, and we have to indicate exactly where a vector is. So is our velocity going at this angle? Is it going at this angle? Is it going this way? What exactly is the direction of the vector? And so there's two ways of talking about this. In math class you might hear about maybe polar coordinates. So for example, I could say that vector A right here, vector A is 5 meters at 60 degrees. So that's polar coordinates. But then the other way that we can talk about a vector is we can talk about the components. And to do this, you imagine that the vector is like the hypotenuse of a right triangle. Okay, so this is 5 and it's the hypotenuse of a right triangle. And so then we can find the two components. And I'm drawing little arrows for a reason I'll explain in a moment. Okay, so if this is 60 degrees, then the sine of 60 degrees is the y component of the vector, so we can call that AY if the hypotenuse is A. Okay, so sine of 60 is AY over A, and so sine of 60 is root 3 over 2 is equal to AY over 5. Or in other words, AY is 5 times root 3 over 2, which is about 4.33. And we can do the same thing with AX. Okay, so the cosine of 60 degrees is AX over A. So if you're kind of struggling with these, you're going to want to look at the handout that's all about vectors. Or take a look in the back of the book for a little bit of extra support with sine and cosine and basic trig functions. And you don't have to be in trig to understand this. This is just sine and cosine that you should have picked up in geometry. Okay, so the cosine of 60 I think is a half, so that means that AX is equal to A cosine of 60, or 5 times a half, or just 2.5 meters. Okay, so AY is 4.33 and AX is 2.5. So what we've done is we've just found the components of vector A. And another way that we can write this is we can say that vector A is equal to its component in the x direction Okay, and then I think your book uses this weird X looking symbol, X hat. This is basically equal to AX. Okay, and then you can say plus 4.33 meters Y hat, and that's a fancy way of saying AY. Okay, and the last thing that we should say right now is that each of these are little vectors themselves, AX and AY. So AX goes this way and AY goes this way, and when you put them together you get vector A, and we'll talk a little bit more about exactly how you do this in the next video.